Okay, now let me go with a sequential circuit flip-flops. Okay, now we all know what I mean by combinational circuit. A combinational circuit is nothing but combination of several gates, okay, where I apply an input and I will get an output for that. That is called as combinational circuit. In this combinational circuit, we know that there will due to some the delay in the gates, so the overall output will have some propagational delay or will have some delay in getting an output, right? Now that is what we call it as combinational circuit. The delay is very minute delay, right? So it is not going to affect as much unless we go with the practical complex circuits. Okay, right. Now, as I told you that combinational circuit is a combination of several gates and where inputs is fed to that and I'll be getting the output. Right. Now this is the circuit diagram or the block diagram for the combinational circuit. Now for this combinational circuit we have the next one that is called as sequential circuit. Now what do you mean by sequential circuit? Sequential circuit also consists of combinational logic circuit. Okay, I'll also apply the input for that. It will also give the output for that. But now some outputs of the combinational logic circuit are also fed, are also stored for a while in this memory element. That means the output, the previous output of the combinational logic circuit is stored in this memory element, and this previous output will again act as an input for the combinational logic circuit. So now that means the combinational logic circuit is involved with two inputs. One is the primary input, the other one is the secondary input. Where the secondary input is coming? The secondary input is coming from the memory element. Means what this memory element has stored? It has stored the previous output of the combination logic circuit itself. So that previous output is fed as the input for the combinational logic circuit, that is the secondary input, right? Now this is what we call it as sequential circuit. Okay, the input and the present state of the memory element determine the output in this case. Okay, so there are two types of sequential circuits. One is synchronous sequential circuit, the other one is asynchronous sequential circuit. Now what do you mean by asynchronous? Asynchronous means I'll just have the input given there, I'll be getting the output, and obviously those previous input will also be fed as an input for the combinational logic circuit. But in asynchronous there is no clock pulse involved in this asynchronous sequential circuit. But now coming to synchronous sequential circuit. Now this is the block diagram for a synchronous sequential circuit, where you can see for the memory element, this is the memory element, this is the flip-flop is a memory element. Now the output of the combination logic circuit is going here, and also the part of the combination output of the logic circuit, combinational circuit, is going to this memory element, that is flip-flop. Now this flip-flop is going to work when I apply the clock pulse. When I when I apply the clock pulse for this flip-flop, then only this flip-flop is going to work. So that means now this circuit is depending on this clock pulse. So once this clock pulse is involved in this kind of circuit, that circuit is called as synchronous sequential circuits. Right? Okay. Now these are all the difference between the combinational circuit and the sequential circuit. Okay. Now the examples for combinational circuits are half adder, full adder, magnitude comparator, multiplexer, demultiplexer, etc. Now the example of sequential circuits are what? Flip-flop, registers, counters, etc. Right. So you can see out the difference between the combinational circuit and the sequential circuit, and I hope you also come to know what we mean by synchronous sequential circuit and asynchronous sequential circuit. Okay. Now coming to the very important thing that is called as flip-flops. Okay. Now what I mean by flip-flop is a circuit that changes from 1 to 0 or from 0 to 1 when current is applied. It is 1 bit storage location. Correct? No? Something like an inverter. Okay. It will always stores the previous value. So when I for an not gate or for an okay, for example, I give a not gate, I take a not gate. So one is applied as an input. Now what is the output I am getting? 0. Correct? Right? When I input is 0 for an inverter or for a not gate, what is the output? 1. Now it is now we call this as an 1 bit storage location. It is storing 1 bit, either 0 or 1. Right? Okay. Now, flip-flops are actually an application of logic gates. It is an application of a logic gates now, right? The most commonly used flip-flop in the implementation of a feedback circuits. Now, what we call it, this is called as feedback circuit. I'll show you, right? Now, the output is taken here. The same output is again reverted back to the same circuit. This is called as feedback. Okay. I'm feeding it back. The output of the same circuit, I'm feeding it back. So that is why it is called as feedback circuit. Okay, right. Now the first thing, there is something like called as latches. The first concept is latch, and then we call, and then later we have flip-flop. Now latches and flip-flop are the basic elements for storing information. Okay. Now one latch or flip-flop can store 1 bit of information. Now the very important thing is, what is the main difference between latch and flip-flop is that for latches their outputs are constantly affected by their inputs as long as the enable signal is asserted. Okay, so now in the latch I apply an input, and also there will be an one enable pin. If I make that enable pin active, then only that latch will work. Now when I give the input for that latch, I'll get the output. Now this is the overall function of a latch. But when I come in case of okay, in case of latch, what happens is that okay, so once I give the input, there is a sudden change in the output also, right? Okay, that is one thing. But when I come to the flip flop, now what flip flop is that I'll give the input, okay, but output is not coming. Why? Why? Because this flip-flop will be having some clock pulse. When this clock is applied, either the rising edge of the clock or the falling edge of the clock, then only the flip-flop will become active, then only it will receive the input, and then it will give the output, right? So always you should remember that flip-flop will be always having the clock pulse, right? I hope now you come to know what is the difference between a latch and a flip-flop. Latch does not contain clock, it will be having an enable signal, but in case of flip-flop it will be having a clock. It will become active only at the rising edge of the clock or falling edge of the clock. Okay, so this is a very important difference between a latch and a flip-flop. There are basically four main types of latches and flip-flops. Those are all SR, D, JK, and T. Okay. The major differences in these flip-flop types are the number of inputs they have and how they change the state. For each type, there are also different variations that enhance their operations. In this chapter, we try to look out the various operation of various latches and flip-flops. Okay, is it clear? So now in the next class we'll see about what I mean by the latch, different types of latches and flip-flops, how it will work. Thank you.